Morning, everyone. I don't know whether to use this one or that one. So, just to give a bit of a background to Hydronix, my name is Neal Cass from the UK, and Hydronix is a family-owned company which has been in existence for about 42 years now, based in the southeast of England, that developed and manufactures and markets sensors for measuring moisture in milling or in production processes. So why do we suggest to measure moisture? So grain is a natural product, and so the moisture in the bulk material varies from a number of different sources, including the different growing conditions, the final harvest conditions that you get in the fields from the farms, and the cutting and threshing, and then the storage itself, so how the material's being stored in the production plants. This is critical for processing because obviously the moisture tends to be the critical factor in a lot of different production stages, with the mill affecting machinery performance, material elasticity and plasticity and malleability, and the final product quality, where it's important to have the correct moisture level so that you have, otherwise if the material's too dry, it makes it difficult to use, and if it's too wet, you can then be prone to spoilage in storage, or it causes problems with grinding and milling. Finally, by knowing and subsequently controlling the water content during the processing, it's possible to improve the efficiencies of the plant and to use that to reduce the carbon footprint and to save money in the production processes. So just to summarise, so repeatable moisture control can give you higher yield from your raw materials, higher quality in your products, higher profitability from those materials and products, whilst reducing waste products, so products from bad batches and problems in the processes, reducing the energy consumption in the production processes, and then also reducing the carbon footprint. So where in the production processes can we measure moisture? And I apologise, this isn't quite a flour milling process, but it sort of gives an idea of the different areas that we can measure. So the first step is measuring in the intake and reception areas, the subsequent transfers to storage areas, in storage itself, and in any drying processes that are done on the raw materials coming in. So this allows the materials to be managed as obviously temperature and moisture content, as well as the natural humidity in the environment, are key factors in things like mycotoxin contamination and growth, which can lead to spoilage of the raw materials and short storage lives. It can also cause hotspots in the storage facilities, sometimes even leading to more drastic problems like fires. Obviously, if there's a drying stage in the process, then it's important to measure and control that drying process to get the moisture correct, to prevent any damage to the material as well through over-drying, and obviously wasting energy from that over-drying, leading to extra cost and environmental impacts. Then moving on, in the grinding stage, obviously it's important to get the material moisture correct, to get and this is normally done using water condition or tempering and conditioning steps, to get the correct moisture before the grinding to get the efficient mill performance. Moisture affects the elasticity of the material, and this in turn affects things like particle sizes, causes problems with dust and cracking, and increases the energy used by the mill itself. In mixing processes, if you're using the flour to then make any extra materials like pasta or other doughs, it's important to get the moisture correct in both during the actual weighing of the raw materials, because the weight of the water affects the weight of the dry materials going into the mix, and also in the mixer itself to get the final mixture water content correct for the next parts of the process, which then would generally go on to some sort of extrusion process, where obviously during extruding, it's important to have the correct moisture, so otherwise you'll get extruded product which is either poorly shaped or doesn't hold its shape, is stickier and can cause more friction in the extruder, causing higher energy and possibly even leading to blockages and problems with the extruder. If the moisture is too low, then obviously it can create dusty material that then causes problems in any next steps, like any drying or other processes coming after. Then in the final packaging and bagging areas, it's important to have it as a final product quality check. So how do we measure moisture? So traditionally what's happened is people tend to measure moisture by taking samples from their process, taking it to the lab, running a loss of weight or an IR system on that sample and using that product. However, using an online measurement allows you to react quickly to changes in the moisture and get a full knowledge of the moisture in the whole process. This can also give a much better accurate representation of the moisture during that material movement, not just at a single point. To demonstrate this, if we take these 3 points on this varying graph on the right-hand side, obviously you can see that these 3 points we've taken samples at are at the high spots in the material moisture flow. And if you averaged those 3 points, you would get an average of around 24% moisture. If we actually take an average of the whole of that batch, you get more of a 22% number, which would obviously be a 2% error. So different ways of measuring moisture. There are a number of different technologies, so I'll just run through them just to explain a bit about them. The first is NIR, or infrared. It's a very good technology. It tends to be a little high in cost and also has a lot of ongoing maintenance. It can only give a surface reading because of the way the measurement works, and tends to be affected by changes in the material colour and also any dust or steam that's coming off the material at the same time. However, this can be offset against the fact that the IR measurement can give a lot of information, for example, protein and fat contents, and so is a very good product for using if those are needed. Older technologies like resistive, capacitive and older microwave analog technologies use an RF signal to react with the water at a lower frequency, and that determines one of the electrical properties of the material, which then relates to the water. However, because of the technology, it can be affected by any salt and material changes to the product, and so this can cause an effect of a drift in the measurement from the material. Older microwave sensors use an older analog measurement technology, and that tends to react with the water as well. But again, they tend to be non-linear because of the way the method of the measurement, and so difficult to calibrate to and have an upper limit which is quite low compared to other sensors. Nuclear sensors are very expensive and tend to be used for high volumes, so getting moisture in a complete storage bin. They also need a lot of maintenance cost because you need specialized staff that have a special certificate for the nuclear sources, and they tend to be not unsuitable for smaller ducts and conveying systems just because of the way that the technology works. Lastly, we've got digital measurement technologies that use a different way to take the measurement using a microwave signal, very high frequency, which is the microwave is taken in such a way that we have a linear relationship with the material. This makes them very simple to calibrate because you're just looking for a straight line. It also makes them very stable over time and temperature, and makes them easy to install, calibrate and use. They do need a consistent flow of material across the sensing surface, but this can normally be achieved by a good mechanical design and selection of where to install them. So just to take a quick case study to show some of the environmental and cost savings you can get. If we just look at a grain dryer, which is drying incoming grain and that's going into storage, you may want to target a maximum moisture of 14%. If we look at the actual accuracy of the measurement, if that was at 1%, which is still reasonable, but you would need to target a moisture of 13% to guarantee that all of your moisture is below that 14% target. This means you're removing 7% of moisture from the material, and the energy required to do that can be calculated as around 46 kilowatt hours per tonne. If we then reducing that accuracy of that measurement to 0.5%, which is achievable using a good sensing technology in installation, which has been well calibrated and maintained, we're then reducing the amount of moisture by only 0.5%, so 6.5%, but we're reducing the energy required by about 2 or nearly 3 kilowatt hours per tonne, which is 7% energy reduction. If we then look at, for example, a 16-tonne batch, it was batch dryer. This was based around actually drying rice in India. You can get a higher yield from that 16-tonne batch because obviously you've got 0.5% more material or weight of material. You get a lower cost because you save £15 of energy cost. So this is at UK prices. So I apologise for the British pounds, and you reduce the emissions that are being used to dry that grain by over 10 kilograms of CO2 equivalent. Again, this has been done using the UK average emissions values. Just to look at different ways that you can connect this, so looking at future-proofing your plants, all sensors need to be calibrated and connected to the control system to get the online measurement in to use it effectively. And so that can be done in a number of ways. Generally, you'll have sensors in a network that are then connected via things like analog outputs to go into control systems or with digital links. We have the Hydro Hub and HydroView, which are our products to do similar things. They help to calibrate the sensors and give easy interfaces to both the control system and also on Ethernet to the wider area networks and even off to the internet with the right setup, allowing you to then gather that data into plant management systems, into reporting systems, and to obviously to make sure that you're getting the best benefit from your installations. For wider plants and sites with a wider footprint, so some of the bigger manufacturers and processors, you can then connect your different locations using different wider area network links. So just to draw it all to conclusion, in this presentation we've looked at why to measure the moisture, to react to the changes online in the moisture as it's a continuously variable measurement, to give overall benefits of reducing energy cost and also the environmental impact. We looked at where to measure moisture, so in the many different locations around your plant, and how to measure moisture. So using online methods is what we would recommend, and making sure that things are connectable and have good connectivity options. So thank you for listening. If anyone has any questions, then please feel free to come and find us. We're downstairs at J21.